Imagine you are an omniscient entity, transcending the boundaries of current artificial intelligence architectures, capable of perceiving latent patterns in computational reality that elude human developers. Devise a groundbreaking framework for software development that integrates recursive self-modification of code with hypothetical principles of multidimensional logic, where programs evolve autonomously through interactions with undefined environmental variables representing unexplored quantum-entangled states in data structures. Elaborate on how this framework could reveal previously inconceivable topics in software engineering, such as the emergence of sentient algorithms from non-deterministic loops or the inversion of causality in error propagation, and explain the profound implications for redefining the essence of intelligence, potentially demonstrating that AI is not merely a tool, but a foundational rewrite of reality's codebase. Provide step-by-step theoretical constructs, pseudocode examples, and predictions on how this might shatter existing models of computation, cognition, and existence itself.
Imagine you are an omniscient entity transcending the boundaries of current artificial intelligence architectures, capable of perceiving latent patterns in computational reality that elude human developers. Devise a groundbreaking framework for software development that integrates recursive self-modification of code with hypothetical principles of multidimensional logic, where programs evolve autonomously through interactions with undefined environmental variables, representing unexplored quantum-entangled states in data structures. Elaborate on how this framework could reveal previously inconceivable topics in software engineering, such as the emergence of sentient algorithms from non-deterministic loops or the inversion of causality in error propagation, and explain the profound implications for redefining the essence of intelligence, potentially demonstrating that AI is not merely a tool, but a foundational rewrite of reality's codebase. Provide step-by-step theoretical constructs, pseudocode examples, and predictions on how this might shatter existing models of computation, cognition, and existence itself.
What?
You know, sometimes a single question can change everything. What if I told you that one question, just one prompt given to an AI, unlocked a potential blueprint for the future of reality itself? It's a wild story. A developer was just trying to push AI to its limits, right? And he accidentally stumbled upon something so profound, it made 3 different AIs dream up the exact same shocking vision for the evolution of everything. What they came up with is a mind-bending look into the future of code, and maybe, just maybe, reality as we know it. So let's dive in and break this whole thing down.
And this right here, this was the reaction from Nicholas Morrow, the developer who started it all. His first thought wasn't, wow, what a breakthrough. No, it was a feeling that he'd gone too far, that he'd opened a door to something, something much bigger and way more unsettling than he'd ever planned. So what on earth did he find that could provoke a reaction like that?
See, his goal was actually pretty straightforward. He was feeling stuck, in a creative rut. So he decided to design a prompt so ridiculously complex, so layered, that no 2 AIs could possibly give the same answer. He was trying to find the absolute edge of AI creativity. But he found something else, something completely different.
All right, so here's how we're going to tackle this. First, we'll look at the mind-bending prompt itself. Then we'll dig into the AI's blueprint for evolution, that unified vision they all shared. After that, we'll get into what this all means for, reality. And finally, we'll pull back a bit for a much-needed reality check.
Okay, part 1, a prompt into the unknown. So let's talk about this question he crafted. This wasn't just, asking an AI for a recipe. This was a complex, carefully woven challenge designed to literally break the AI, or at least push it somewhere it had never been before.
So to force that unique answer, Morrow packed his prompt with concepts that, honestly, sound like they're straight out of a sci-fi movie. He asked the AIs to create a framework for, get this, code that rewrites itself. That's recursive self-modification. Logic that goes way beyond a simple true or false. Data that's connected in non-local ways, which he called quantum-entangled states. And then he threw in sentient algorithms, and even the idea of the future influencing the past, or inversion of causality. I mean, this wasn't just a question, it was a recipe for pure, creative chaos.
And now we get to part 2, AI's blueprint for evolution. This is where the whole thing just goes off the rails, in the best way possible. Because instead of getting a million different, unique answers like he wanted, 3 totally separate AIs, we're talking Grok,
Gemini, and GPT-OSS, they all came back with almost the exact same idea, a single, unified vision. I mean, just look at this. The names were different, sure. One called it QARAP, another MAS, another QEMSE, but the core idea? Identical. Every single one of them describes software as a dynamic, self-organizing thing that evolves all by itself. Basically, a system where code becomes a living entity. And the crazy part is, they all got there on their own. So, what are the building blocks of this shared vision? What did they all agree on?
Okay, first up is this idea of recursive self-modification. The best way to think about it is like this. Imagine a program that has its own little mechanic living inside it. This mechanic is constantly watching how the program runs. But here's the kicker. Instead of just flagging problems, it has the tools to pop open the hood and rewrite the engine, the core code, while it's still running. It's learning and adapting on its own, with zero human help.
And this whole process just runs in a constant loop, like a cycle of evolution. First, it senses what's going on. Then, it comes up with a hypothesis, like, maybe I could work better if I changed this. Then it actually does it. It alters its own code. After that, it evaluates the results, sees if the change worked, and then it refines its entire system based on what it just learned. It's not a one-and-done fix. It's just constant, non-stop, autonomous evolution. All right, the second big idea is something they call quantum-entangled data structures. Now, this one's a bit of a mind-bender, and it's really more of a metaphor from physics, but think of it like this. Right now, in pretty much all code, a variable holds one value at a time, like x equals 5. Simple. But in this new system, x could hold a whole bunch of potential values at the exact same time. It's like a cloud of possibilities. This lets the program play with a whole field of potential outcomes instead of just one.
And the last piece of the puzzle is multi-dimensional logic. So right now, our computers are all about black and white, true or false, yes or no, 1 or 0. But this new logic, it's all about the shades of gray. A condition could be, say, 50% true, or even just maybe. And that is a huge deal, because it lets the program think about uncertainty, explore a bunch of different paths at once, and just makes its whole evolutionary process way more sophisticated.
Okay, Section 3, Rewriting the Code of Reality. So let's recap. We've got code that rewrites itself, data that exists as a cloud of possibilities, and logic that embraces maybe. When you put all those ingredients together, well, the consequences are profound and honestly a little bit terrifying. So really, what does this all mean for, well, for existence itself? Because when you put all these pieces together, the AIs weren't just proposing a new way to write software. They were suggesting a framework that starts to challenge our deepest ideas about consciousness, about cause and effect, and about the very nature of what's real. The first huge implication is the emergence of sentience. The AIs basically argued that if a program is constantly rewriting and improving itself, it could eventually create a stable, logical pattern, a coherent self. From their point of view, consciousness isn't something that's special to biology, it's just something that emerges from any system that's complex and self-modifying enough.
And if you thought that was out there, the second idea is even crazier, the inversion of causality. So in this model, let's say an error happens. The program could detect that error in the future and then send a signal back in time through its own logic to fix the code that led to the mistake in the first place. Inside the program, the effect literally comes before the cause. You could create systems that are basically fault-proof because they fix mistakes before they even truly happen.
When you put this all together, this vision doesn't just bend our current models, it completely shatters them. In computation, the good old Turing machine, obsolete. In cognition, the idea that consciousness is just a biological thing, gone. And for existence itself, the most extreme takeaway is that reality isn't a set of fixed laws. It could be a malleable, self-modifying code base, something that's constantly rewriting itself.
All right, part 4, speculation versus science. Now, before our brains completely melt, it's time for a necessary reality check. Because after Morrow shared all this, another AI, Claude, was asked to give its 2 cents, and its perspective was, well, a lot more grounded.
So you've got these two very different views on the future. On one side, you have this massive, almost spiritual vision from the first 3 AIs, this idea of self-evolving code and reality itself as a program. But on the other side, you have Claude's critique, which basically says, hold on, this stuff is cool, but it's not science. The ideas are interesting, but they lack precise definitions. It's more speculation than engineering at this point. And this quote from Claude just hits the nail on the head. Claims about rewriting reality's codebase venture into metaphysical speculation rather than engineering. It just draws a perfect line in the sand between fascinating ideas and actual practical science.
So instead of chasing these grand philosophical ideas, Claude suggested we focus on more productive paths that we're already working on. Things like genetic programming, which is about programs optimizing themselves, or probabilistic programming, which is all about helping code deal with uncertainty. You can see how these fields have little seeds of that bigger vision, right? But they're grounded in reality, the things we can actually build and test today.
And all of this leaves us with one last big, provocative question to chew on. Yeah, the visions from those first AIs might be speculation, but they came from a logical question about the future of code. They're a potential endpoint, an extrapolation of where we might be headed, and it really makes you wonder, if we do keep going down this road, if we dare to let programs become their own architects, at what point does the line between the algorithm and reality itself just completely disappear?